Okay, everybody out there watching, hi and welcome to our notes on 7.2, which is solving systems of linear equations using substitution. Okay, I've got three quick examples I want to give you, but first let's talk about what substitution is. You've done this before. If I give you the equation y equals 2x and I say evaluate or plug in x equals 3, or if I give you a table of values of 3, all you're going to do is take that 3 and replace it where x is. So you get something that looks like this. Right? 2 times 3, or you find out that it's equal to 6. That's what we're doing. That's what substitution is. Taking what one form is and having it being equal, x and 3 are the same, and replacing the other value in there. So that's what we're going to do, but we're going to do that with equations, particularly two linear equations. So what's that look like? What we like to do is to have one equation solve for at least one expression. Well, okay, one expression. So that means solve for y. That's really kind of what that means for you. Can it be x? Yeah, but you need to have something that looks like that. An x or a y isolated by itself. Why is that? Because we're going to take whatever y is in the other equation and put that in there. It's generally a decent habit. A lot of kids like to do this, is just solve everything for slope-intercept form. Is it always the easiest? No, but it is a way to do it. And you're comfortable with it, so it's not a bad thing to do. All right, so once you do that, you substitute, you get this linear equation, you plug it into the other one, and then you go ahead and solve. You're going to get one coordinate out of it. You can already see down here in this example I'm looking at, you're going to get one coordinate out of it. You got to plug that or substitute it back in to find out what the other coordinate is, because when we're all said and done, you should end up with a coordinate point for your solution for these. So let's get into our examples. I'm going to do an easy one first. I'm going to do B. I know it's crammed in here, but you'll be okay. So our first goal was to make sure that one variable is solved for. Hey, y equals. It's solved for. Check, step one's done. Step two then says take whatever y is equal to and find y in the other equation, right there, right, and plug that in. Why do we do that? Because look what happens. Now we get one equation which has two unknowns, x and y, but now that we plug 2x in there, we only got one unknown. So we can solve it now because we can't solve with two unknowns. So 7x negative, now this y becomes that 2x. Use parentheses to show substitution. It helps keep things like this negative to work, right? Because that needs to be multiplied there. So it's going to become 7x minus 2x equals 15. And at this point, we're just going to go ahead and solve. Combine like terms, and 7x and negative 2x becomes 5x, which equals 15. Divide by 5, part of our solving process, right, equals 3. That's our first coordinate. Awesome. That was pretty easy. This is the easiest one you're going to see. Then, I'm going to switch colors so you can see this clearly. I'm going to take the 3 and move it back up into either one of the equations. It doesn't matter. Guess which one I'm going to pick? The easier looking one. Okay, that should always be your scenario. Pick the easiest looking one. So y equals 2 times 3, and that equals to 6. Or y equals 6, I should say. So your x coordinate is 3. Your y coordinate is 6. Remember that both of those go together to make your solution for this, which is the point 36. That's the easy form. Again, don't forget to pause the notes, write all of these down so that you have some basis. You can see some fraction work in here. I want you to be able to do that. So what I'm going to do is I'm going to do part of this substitution because I want to keep it quick. You solving with fractions is something you need to work out. I could go through it in the notes, but I want to keep them short. So let's just talk about how to substitute. So looking at this one, it's another easy form. I've got two equations already. Both are solved for y. So I can substitute in, but here's the thing, when they're both solved for y, it looks like this. Watch, here's what happens. I'm going to take this 2x plus 2, because it's equal to y, and I'm going to put it right there. Well, it just ends up looking like you set these 2x plus 2 equal to negative 3x plus 4. That we've seen a lot of. From here, you would solve this out. Get your terms on the same side. There's your equal sign, so be careful. Those x's are on opposite sides. So I'm going to move this one over. It's going to keep me positive. So 3x to the other side. Those turn to 0. And I'm going to move this 2 to the other side. Mr. Hallam, are you doing 2 steps in one? Yeah, I don't have a lot of room. So those turn to 0. What do I have left? These 2x terms, which make 5x on the left, equal to, drop my equal sign down, that's 0, so it's not there anymore. And 4 minus 2 is 2. From there, I'm going to divide by 5, x is equal to 2/5. Okay, the work from there stands. You take that 2/5, I'll change my color and plug it in. This part is for you to do. It doesn't matter which equation you picked, but if I'm looking at the one I already did, I'm going to plug it in up here to that x right there. So what I did is 2 times 2/5 plus 2. Oh, fraction work, right? 2 times 2/5, right? So this turns into 1, multiply numerator, multiply denominator, so you get 2 times 2, which is 4, and 1 times 5, which is 5. but I've got to add that to 2. But 2 is a fraction of 2 over 1. It doesn't have common denominators, so I need to get them. This is something you must do from now on because you cannot use decimals. So you're going to find a common denominator. Do that. You multiply by some form of 1, meaning some value over itself, right? In this case, 5, because that gives us the common denominator of 5. So you jump up here, 4 fifths plus 10 fifths equals 14 fifths. That's your solution. Get used to fractions. Get used to ugly numbers. And those aren't even ugly. You ready? Let's do another one. So I'm going to jump down here. What's the difference between this set of problems and the ones you did before? Well, the leading coefficient, or one of the variables, isn't solved for. Solve for, solve for, solve for, solve for, solve for. Look at the first one here. Nothing solved for. That's the only extra piece. It's just one extra step you got to do. What's this note say? Try to find one that has a coefficient of 1 or negative 1 and solve for that one. Which one? The highlighted one. See, it's a y. If I don't pick this y, if I pick this, I've got to move the 3x and then divide by 2. That's 2 steps. If I pick this y here, all I have to do is move the 6x over, right? So let's do that. Add 6x to both sides. Those turn to 0, y drops down, equals, I'm going to move the 6x in front because that's my math side of me. I like to have it in slope-intercept form. So I've got this. Now I've got a y equals. I can, at this point, take the other one, solve for y, so I can do something like this, where I just set them equal to each other like we did before. That's fine and dandy if you want to do that. I don't mind doing this, though. I take this y and I plug it into the other equation. Can I go back into the original? No. I have to use the other one then. So I'm going to plug it in there. So I'm going to start writing it out. 3x plus 2 times this new quantity, because that's what y was. It was y, but now it's 6x plus 7, or minus 7, equals 4. Distributive property, right? Multiply that out. 3x plus 12x minus 14 equals 4. Combine like terms. So I get 15x minus 14 equals 4. Add 14 to both sides. 15x equals 14 plus 4 is 18. Oh, you ready? Here's where it gets ugly. Divide by 15. That's the last thing we have to do. So we find out that x is equal to 18/15. Yes, you have to deal with that. Yes, you have to plug that back into one of the two equations. You can see that I plugged it back in right here. So that's where it went in. That x-coordinate went right there for that first equation. So you can see the work from here on out. You can see that you have to deal with fractions. Yes, I subtracted a fraction to the other side. Look what I did here, though. This is interesting. We've been dealing with this for a while. Clearing fractions is perfectly great skill for this. So I cleared out this 5 because it was easy. Multiplied all 3 terms by 5. This deleted out, so it was gone. Look what I get. That's easy to deal with. I'll scroll down here to the bottom. You can see that I get 2/10 or 1/5. So when I'm done, there's my solution. Again, make sure that you write this down. You need to see these answers. Look at these answers. 23/10 and 8/5. Get used to those. You have to keep it in fraction, no decimals, okay? So I'll let you read through the work. That part you can handle. But the substitution part, you should be pretty comfortable with. That wasn't too big. So make sure that you do your questions that go with this, and we'll see you in class for whatever things you need to ask. All right, have a good day.